Let's see the problem longest increasing subsequence. So let's understand this problem first. And we have already seen this problem in the last video where I used the technique DP array, and that is the n square solution. And today we are trying to solve using another approach, that is binary search technique. And then the runtime, the speed will be, you can say, n log n. Let's understand this problem once again. So here we need to find out longest increasing subsequence, so 10, and if you start from the 10, then we need to find out the next increasing number, that's a 101, so that's a 2, so we cannot take this 2. So we can start, if you start from the n, again the next one is 101, this again length is 2 as per given here. If you start with the 2, then 2, and the next increasing sequence is 3, and then 7, and then 101, and that is the maximum length here. And we can say like result is 4. So in a last video when we use the DP array, we use internal or inner for loop. Like let's say each like we are at 7 and we need to find out what is the longest increasing sequence till this place. Then there was an inner loop, and that started from the 0 and come till here, and it finds the longest increasing sequence till this number, and we maintain the max. And in this way we went to each value and then iterated from the 0, and that was the easy solution, but that's a n square solution. So today we'll see the binary search technique. And if you do not know the binary search, then you can go in my videos, and it's the playlist, and or you can search the binary search, and you can find binary search technique, and then you can learn that binary search technique from there. So I assume that technique is very easy, but anyway, you can go and watch that binary search technique video, and also you can watch the previous video to get the better idea about the first solution. And for the second approach, let me copy this example, and then we'll see step by step what I'm going to do, and then we'll see the code. So let's move to the another screen, and I have put the same example here. And what we do using this technique, and this is a efficient way compared to the previous video. But first we maintain one max variable, and in a max variable I'll put the first number 10, and then I will start iterating from this 9 to all this end number. And then I will also maintain one temp array. So in a temp array, just temporary array, I will put the 10 in the beginning. I put the 10 at in a max number, and here also put the 10 here. So when I iterate through this, I will get this number 9, and if the 9 is the bigger than this max, then I can put that 9 to the temp array. But that is not the case here. 9 is not bigger than this max. So if the 9 is not bigger than max, then our next responsibility is put the 9 if at the same place in the temp array if the 9 exists. So 9 also doesn't exist, then we'll see what is the from the 9 we'll see any smaller number before the 9, we can put it there, but there is no smaller number, then we can replace 10 with a 9. So I'll replace 10 with 9, and now the max is 9. In the same way we'll see the 2, and 2 is also not greater than this, then I'll replace this 9 with the 2, and then I'll put the max is 2 here. Now I see the 5 is greater than 2, then I will append that 5 here, and I'll put the max is 5. In the same way I'll come to 3, and for the 3 I see 3 is not greater, then I will check if the 3 exists here. No, then I will put the 3 right after a smaller number. So 2 is the smaller, and right after this 2 is the 5, so I will replace this 5 with 3. So right after the smaller, any smaller number, so 3, and then now max is 3 here. So we'll see again 7, the 7 comes here, and then 7 will see that's a greater than the max, then I can put the 7 here, and the max is 7. In the same way I put the 101 here because that's a higher number, and then I can put 101 here, and then come to the 18, and 18 I'll see the 18 exists here. No, 18 doesn't exist. 18 is smaller than this. Then I'll check that which is I'll put the 18 right after the smaller number. So this is the 7 is a smaller number, and just before this 18, and after that there's a 101, then I will replace this with the 18. And then at the end, I can check the length of this temp array, and I can return that length, and that is the max increasing sequence, because this is also a solution for that. So, and that's the max increasing sequence. So we'll see that technique here. So when we see the greater number, we easily add it in a temp array, but when we find some number need to be replaced, then there we need a binary search function. So we'll see the code and we'll get the clear idea again for there. So this is the code. I maintain one temp array, and also I have maintained at the top, if you see, there is a max variable. So the first of all, I put the first number to the max, and I'm iterating from 1 to the end of this array, and I'm checking if the num_si is the next number, like let's say 9. If it is greater than max, then I will add that in a temp array, and I will also say that is the max, but this is not the case here. 9 is not max. Then I'm saying, okay, put item in same place. If that item exists in the temp array, I'm passing the temp array here. If item exists, this num_i item, that is like let's say 9 exists, put that in a same place or right after a smaller item. So that's the function, and the real magic is in this function. And then once we get this temp array, then here we can just return the length of this temp array, and we'll get the answer. So, and this function is put the item in a same place or right after the smaller item. That is exactly done by this binary search technique. So this function is nothing but binary search techniques. We'll do the binary search on temp array, and we're searching the item. So if you see this logic, exactly it's a binary search here, beginning and end, and we're checking a beginning less than end, and we're also finding the mid number, and then we're checking if the number we find, the mid number, okay, we do something here. So we found the number. So then once we found, like let's say we found the number, then what we do, so we have added some additional thing here, like we're just checking if you find the number, and if that number is the last in a temp array, that's if the last in a temp array, then we just say that, okay, that is a max. So that is the max, because the first time there was a 10 and we replaced 10 by 9. If you find that number, it's not that number is not there, but if you find the number, and if you come here and there is just only one item, or maybe the 2-3 items, and that item is, if you find the item and that item is end, then we say that is the max item. So we are just maintaining the max item here. And again, so that's the one additional piece, that's some maintain the max item and return if you find the number. But if you do not find the number, then the same way we are doing temp array mid. If you do not find, then mid -1 if item is less than, otherwise mid +1. So this is exactly the similar piece in a binary search. And then when we come out of this binary search thing, then temp array beginning we are we are putting this item. So temporary beginning, when we say this logic and putting this item here, so this is exactly what I said, like if you do not find a number, then it will find the place that is one right after a smaller item, and then we can put the item there. So here we need to put the temporary beginning. So that's a additional piece of thing. And if it is the if the this beginning is the first item, then we can check if there's a first item, that means there is just only one item. Then in that case we need to maintain the maximum. So till here, this is all the binary search logic. The only additional change we are doing two things, or we can say three things. If it is we find the item, and if it is the end of the item, we make it max item. And if the item is item is in the beginning, or there is only one item, then we make it max. And then this is the magical line where temporary beginning, and we put the item. And that's the logic about the longest increasing sequence. And if you see here, 93, yeah, so yeah, that's the better solution, I can say. So that's all for now. Thank you.